Hello students, welcome back to the new session of the classification of elements, the periodic table. Now we completed one part of the chapter, that is we completed the earlier classifications, nothing but Daubernier classification, Newland classification and Mendeleev classification. Now we are going to enter into the modern periodic table. Okay, this is the new classification and the present classification. Based on this classification, now the elements which were discovered, the total 180 elements were placed. And this is an important classification. So, all my dear students, listen very carefully. And in the public examination, we are going to have a question: what define modern periodic law and what are the salient features of modern periodic table? Okay, this is the question we are going to have in the public examinations. So, all my dear students, listen very carefully. Okay, now modern periodic table. Before going to enter into the salient features of modern periodic table, first of all, you should know modern periodic law. Based on a law, the modern periodic table was designed. What is the law? That is modern periodic law. What is modern periodic law? Here is the statement of modern periodic law. The properties of the elements are the periodic functions of their atomic numbers. Here, this is an important point, my dear students. This is a very important point. The properties of the elements are the periodic functions of their atomic numbers. Atomic numbers. What is meant by here? Here, if you observe, if you compare with the modern periodic table with the earlier classifications like Daubernier classification, Newland classification and Mendeleev classifications, all the classifications were based on the atomic weights, right? Is it right or not? All the classifications are based on atomic weights. But the modern periodic table classification is based on atomic number. Why they took atomic number? Particularly this modern periodic table was given by Moseley. Modern periodic law was given by Moseley, scientist. Why he took atomic number as a classification, as a criteria for classification? Here is what is meant by atomic number. Atomic number represents number of protons or number of electrons It means indirectly we can say that the modern periodic classification is based on the number of electrons. Why? Because why he took number of electrons as a criteria in his classification? Electrons are responsible for formation of chemical bonds, and electrons are responsible for getting the different properties. Okay, and from the electrons we can write the electronic configuration. With the electronic configuration we will get valency electronic configuration. Valency electronic configuration is responsible for all the properties of an element. Means indirectly atomic number decides the properties of element. Atomic weight doesn't have any sort of importance in deciding the properties of elements. But earlier classifications took atomic weight as a criteria for deciding the properties of elements. That's why the earlier classifications had become failure. Atomic weight doesn't play a vital role in the classification. That's why the earlier classifications got failure. In order to overcome the main failure, The atomic weights were replaced with atomic numbers. Why? Because atomic numbers means nothing but a number of electrons, where the properties of an element will be decided based on the number of electrons. Okay, my dear students, based on this modern periodic law, we are going to design the modern periodic table. We designed already the modern periodic table. Now let us enter into the modern periodic table. Let us learn more about the modern periodic table. Are you ready? It's very interesting topic. Let us see. Yes. First, here we are going to learn the modern periodic table as a salient features of modern periodic table. Under salient features, we have three things to be discussed. One is groups, second one is periods, and third one is blocks. Actually, in your textbook, the first one is given as a blocks, and the second one is given as a groups, and the third one is given as a periods. But I am going to explain in this order. First, I am going to explain groups, second, I am going to explain periods, and the third, I am going to explain blocks. These three are the salient features of modern periodic table, which explains about everything of the periodic table. Okay, now shall we enter into the first salient feature, that is the groups of the modern periodic table? Are you ready? Yes, let us enter into it. Yes, first we are going to discuss about the groups. What are meant by groups? In the Mendeleev's periodic table itself, we came to know what are meant by groups. The columns in the periodic table, the horizontal columns in the periodic table are called groups. Here you are finding the design of the periodic table, and the horizontal columns in this periodic table, which is represented with different colors, are called groups. Let us count total how many groups here we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Totally there are 18 groups in the periodic table. How many groups are there in the periodic table, my dear students? 18 groups. Here itself the numbering is there. Totally here we have 18 groups in the periodic table. All the 18 groups were divided into two subgroups. All the 18 groups were divided into two subgroups. 1, 2, 13 to 18 are called as A subgroup. A subgroup, and third to 12 are called as B subgroup. 1, 2, 13th to 18th subgroup. It means first subgroup, second subgroup, and 13th to 18th subgroup are called as A subgroup, and third subgroup to 12th subgroup are called as B subgroup. Third, fourth, fifth, sixth, 7, 8, 9, 10, 11, 12. Okay, why? What is the difference between A subgroup and B subgroup? Why the A subgroup and B subgroup division took place? Okay, let us see. Let us see here. Okay, my dear students, why there is a division between A subgroup and B subgroup? I will show to you. It's an interesting one. Yes, here if you observe carefully, here this is a periodic table. This is a periodic table. Yes or no? Okay, let us see why the groups were divided into A subgroup and B subgroup. Here is the periodic table, my dear students. 1A group, first group, second group is called as first group, second group. 13th group to 15th group are called as A subgroup. Third group to 12th group comes as B subgroup. What is the main criteria for dividing the elements, dividing the groups into two subgroups, A subgroup and B subgroup? Here, let me take few elements, then you will get an understanding. Let me take calcium. Let me take calcium. And let me write the electronic configuration of calcium. The electronic configuration of calcium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 is the electronic configuration of calcium. In the calcium, there are 20 electrons. Once you observe in which orbit the 20th electron is being entering. Yes, 20th electron is entering in 4th orbit. Yes or no? And the 4th orbit is the last orbit. In calcium atom, the last electron is entering into the last orbit, which is the highest orbit. Okay, let me take an element in the group B. Let me take cobalt. The electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7. This is an electronic configuration of cobalt. Once you observe the electronic configuration of cobalt, in which orbit the 27th electron is entering? Yes, the 27th electron is entering in 3rd orbit. Yes or no? But which is the highest orbit in the cobalt? 4th orbit is the highest orbit in the cobalt. But the electron, the last electron is entering into the 3rd orbit. Okay, let me take one more element for clarification. Let me take Tc. What is Tc? Tectinium, Tc. The electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. By this 30 completed. 3p6, 3d10, 3p6, 5s2, 4d. Okay, here 10, 30, 36, 38 and here it is 43. 38 plus 5, 43. That is 4d5. Okay, once you observe, 43rd electron is entering into the 4th orbit. But the last orbit is 5th orbit, 5s2. Yes or no? By observing the principal quantum number in the electronic configuration, we can find which is the last orbit. 5th orbit is the last orbit. But the last electron is entering into the 4th orbit. That's why the elements are placed in B group. Okay, but in the calcium, the last electron is entering into the 4th orbit and 4th orbit is itself the highest orbit. That's why the element is placed in A subgroup. Had you understood why we divided the groups as A subgroup and B subgroup? The elements under A subgroup, okay, the last electron will be entering into the last orbit. If the last electron or the differentiating electron enters into the last but one orbit or last to the second orbit, all the elements belongs to B subgroup. This is the main criteria for dividing the elements into A subgroup or B subgroup. Is it clear? Is it clear, my dear students, why we divided the elements into A subgroup and B subgroup? Okay, now let us see about, now here we are not going to discuss about B subgroup elements, my dear students. Just we are going to discuss about A subgroup elements. Here A subgroup elements are taken as 1A, 2A, 3A, 4A, 5A, 6A, 7A and 8A. These are A subgroup elements. Totally we have 8 A subgroup elements. Now we are going to discuss about 8 A subgroup elements. Okay, are you ready to discuss about 8 A subgroup elements? Yes. Let us discuss about 1A group elements. 1A group elements. What are the elements comes under 1A group? You need to remember the elements names compulsory, my dear students. Yes, the first one is lithium, and the second one is sodium, and the third one is potassium, the fourth one is rubidium, and the fifth one is cesium. These all are the 1A group elements. See here, yes, these all are the 1A group elements. Hydrogen will not be considered as 1A group element. I said you, hydrogen shows a peculiar nature. It won't be considered under any group. It is an isolated element in the periodic table. Okay, hydrogen is not considered as an 1A group element. Lithium, sodium, potassium, rubidium, cesium and francium. These elements are called as 1A group elements. Okay, yes. Now let us learn some more information about 1A group elements, my dear students. Yes, 1A group elements are also called as 1A group elements are also called as alkali metals. 1A group elements are also called as alkali metals. Okay, what are 1A group elements? Lithium, sodium, potassium, rubidium, cesium, francium. These all are 1A group elements and they are all called as alkali metals. Why they are called as alkali metals? What is meant by alkali? Alkalis means bases. What is meant by alkali? Alkali means bases. All the metals forms bases. Metals means not the metals. All the oxides of these metals, when they are dissolved in water, they forms alkalis or they forms bases. So all these metals are called as alkali metals. For example, if you take sodium, oxide of sodium is Na2O, and if it is reacted with water, Na2O plus H2O gives rise to NaOH, which is an alkali or base. In the similar way, if you take rubidium, Rb2O plus H2O gives rise to RbOH. This is also called as alkali or base. In this way, all the metals, metal oxides, when they react with water, they form bases. So these metals are called as alkali metals. What they are called as? Alkali metals. Okay, and second point, what is the general valency electronic configuration of these elements? The general valency, for every group you need to remember what is the name of the group and what is its general valency electronic configuration. General valency electronic configuration means the outermost electronic configuration is called as valency electronic configuration. Let me show to you. For example, if you take lithium, the electronic configuration of lithium is 1s2, 2s1. Okay, 1s2, 2s1. Sodium, the electronic configuration of sodium is 1s2, 2s2, 2p6, 3s1. The electronic configuration of potassium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. The electronic configuration of rubidium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4p6, 4s2, 4s2, 3d10, 4p6, 5s1. 4p6, 5s1. In the similar way, cesium 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4p6, 5s2. Next, 4d10, last finally you will get 6s1. It is a lengthy one. I am going to write last 6s1. In the similar way, last you will get 7s1. Okay, now what is the valency electronic configuration? Now here if you take the lithium, there are 3 electrons. In which orbit the third electron is entering? Yes, second orbit the third electron is entering. The respective electronic configuration, that is 2s1, is the valency electronic configuration of lithium. In the similar way, take sodium, 11. Number of electrons is 11. 11th electron is entering in 3s1. So 3s1 is the valency electronic configuration of sodium. In the similar way, potassium, 4s1. 4s1 is the valency electronic configuration of potassium. In the similar way, rubidium, the last electron is entering into the 5s orbital. So 5s1 is the valency electronic configuration of rubidium. In the similar way, cesium, the last electron is entering into the 6s orbital. So 6s1 is the valency electronic configuration of cesium. Rubidium, the last electron is entering into the 7s orbital. 7s1 is the valency electronic configuration of rubidium. Had you understood what is the valency configuration of element? Okay, in which orbital the last electron is entering, that orbital will be the valency electronic configuration of that particular atom. Now, the valency electronic configuration of lithium is 2s1, sodium is 3s1, potassium is 4s1, rubidium is 5s1, cesium is 6s1, francium is 7s1. Once if you observe carefully, 2, 3, 4, 5, 6, 7. Which is the orbit number? Orbit number is represented with N. Orbit number is represented with N. And commonly we have S1. So, the general valency electronic configuration of the alkali metals or 1A group elements is NS1. The general valency electronic configuration of alkali metals or 1A group elements is NS1. Is it clear, my dear students? First, 1A group elements are also known as alkali metals, and these are the elements under 1A group, and these are their electronic configurations. And the general valency electronic configuration of alkali metals is NS1. Okay, now Let us go to the next group, that is 2A group elements. 2A group elements. What are the elements comes under 2A group? Let us see. Beryllium, magnesium, calcium, strontium, barium. These all the elements comes under 2A group. Once you observe the periodic table, yes, beryllium, magnesium, calcium, strontium, barium and radium. All these elements comes under 2A group elements. Now let us discuss some more information about 2A group elements. 2A group elements are also known as alkali earth metals. 2A group elements are also known as alkali earth metals. Why they are called as alkali earth metals? Why? Because already we know 1A group elements are known as alkali metals. Why they are called as alkali metals? Their oxides dissolved in water forms bases. Similar way, 2A group elements are called as alkali earth metals. First of all, why they are called as alkalis? Similar way, their oxides dissolved in water forms bases. For example, if you take beryllium oxide, BeO plus H2O gives rise to BeOH taken twice. BeOH taken twice. Next, MgO plus H2O gives rise to MgOH taken twice. In this way, all the elements under 2A group, their oxides dissolved in water forms the bases. That's the main intention why we call these as alkali earth metals. That is first main reason for saying alkali. Next, earth metals. Why we are calling them as earth metals? Why? Because all these metals are obtained in earth crust. Where all these metals are obtained? All these metals are obtained in earth crust. So all these metals are called alkali earth metals. Okay, yes. Now let us find out what is the general valency electronic configuration. First of all, the valency electronic configuration, let us find out. In order to find valency electronic configuration, let us write the electronic configuration. Beryllium 1s2 2s2, magnesium 1s2 2s2 2p6 3s2, calcium 1s2 2s2 2p6 3s2 3p6 4s2, strontium 1s2 2s2 2p6 3s2 3p6 4s2, 3d10 4p6 5s2. That's all. Barium, and here we have one more element, my dear students. I forgot to place here in the presentation, that is radium. Barium, radium. Radium. Okay. Now in the similar way, all will get last finally 6s2. In the similar way, all will get finally 7s2. Now what will be the valency electronic configuration of each element? For first one, the valence electronic configuration is 2s2, second one 3s2, third one 4s2, fourth one 5s2, I explained you how to write valence electronic configuration 6s2 and 7s2. Okay, those are the valence electronic configuration. Once you observe here, 2, 3, 4, 5, 6 and 7. Okay, represents orbit number, so commonly we can take n, and all have s2, so s2. n s2 is the valency electronic configuration, general valency electronic configuration of alkali earth metals. Had you understood what is the general valency electronic configuration of alkali earth metals, which is equal to ns2? What is the general valency electronic configuration of alkali metals? It is equal to ns1. Okay, by this we completed the 2a group. Let me end up the session. In the next upcoming session, we will discuss about the remaining groups, that is 3a to 8a groups. Thank you.